Okay, so for the locus of points, that's the set of all points that satisfies the condition. We're going to think of our conic sections. The set of all points that the sum of distance from two fixed points to each point on the locus is constant. That is an ellipse. Because the sum is adding. So if I think of B, the set of all points at the difference, that's hyperbola. Equidistant from one point is a circle. And from equidistant from a point and a line, this line would be the directrix, so this is a parabola. Okay, so first graphing the equation, I like the constant or the coefficient to be with the non-squared term because 1/4 equals 4p, which means 1 equals 16p, so 1/16 is p. Y squared equals x is going to be a parabola that opens left and right, or right, but because this is positive, it opens to the right. And my vertex is at 0, 0. So it's sketched like this. And my focus is 1/16 inside the parabola. So the focus is at the point over 1/16 up 0. And the directrix is the vertical line, 1/16 to the left of the vertex. That's the line x equals negative 1/16. Now for B, again, I'm going to solve and get the squared term by itself. So y equals x squared is a parabola that opens up or down, but because it's negative, it's going to be down. And again, my vertex is at 0, 0. 4p equals negative 36, so p equals negative 9. Here's a sketch of the parabola. So negative 9 units down from the vertex is the focus. So that is going to be at 0, negative 9. The directrix is 9 units up from the vertex. It's going to be a horizontal line here. So that's the line y equals 9. I can plot my focus too. For a circle, our equation is x minus h squared plus y minus k squared equals r squared. Passes through this point whose center is the origin. Oh good, so that makes it x squared plus y squared equals r squared. Well, if it passes through the point negative 3, 4, and it centers the origin, this is my radius. I have a nice little triangle here, over 3 and up 4. So using Pythagorean theorem, we get 5 is the radius, or 25 is r squared. So x squared plus y squared equals 25. I'm sorry, x squared plus y squared is 25. Okay, sketching a graph of the circle. This is a circle. So the center is at 0, 0. And the radius is 4. So I'm going to go up 4 and right 4, down 4, and left 4, and then connect the dots the best I can in a circle. An ellipse that has center 0, 0, so that's x squared over plus y squared over equals 1. If the vertex is at 0, 10, and a co-vertex is at negative 8, 10, that means it's an ellipse that's more vertical. So a squared is under y, and b squared is under x. Well, 10 is going to be our a value, and negative 8 is going to be the b value, or 8. So we get x squared over 64 plus y squared over 100 equals 1. Describe the graph. The center is at 0, 0. It's an ellipse. Because the bigger value is under x, it's horizontal. Let's say where the vertices are. It's going to be 6 in each direction on the x-axis. So that first vertex is 6, 0, and the other one's negative 6, 0. And then the co-vertices, the square root of 16, that's 4, so 0, 4, and 0, negative 4. Can even locate my foci. So 36 minus 16 equals c squared. So c is root 20, which, that's 4 times 5, so 2 root 5. So my foci are along the major axis. So that's at 2 root 5, 0, and negative 2 root 5, 0. And that's the foci. Okay, so A is a hyperbola. The center's at 0, 0. And I'm going to make my rectangle 8 in the x direction. And 8 in the negative x direction. I'm going to count by 2's since I run out of space on my graph here. So let's see. So here's 8. And this is negative 8. And then I need, the square root of 36 is 6, so I'm going to go 6 in the y direction. And then this rectangle is going to help me draw my hyperbola. My asymptotes are the diagonals of this rectangle. Because x is first, it opens in the x directions. And by drawing those diagonals, I know how wide my hyperbola goes. The center is at 0, 0, and my vertices are at 8, 0, and negative 8, 0. Now for this one, I need to divide everything by 36 before I start. So we have y squared over 4 minus x squared over 9 equals 1. So again, my center is at 0, 0. I'm going to count 2 in the y direction for my rectangle and 3 in the x direction. The diagonals are my asymptotes. Oops, I missed that one. And because y is first, it opens in the y directions. My vertices are at 2, 0, and negative 2, 0. Okay. I'm going to first label what each type of equation is to help me with my matching. This is a parabola, a circle, an ellipse, a hyperbola, and a hyperbola. Now both of my ellipses, oh no, this ellipse is the vertical direction, and this ellipse is in the horizontal direction. Well, here's my only parabola. Here's my only circle. A vertical ellipse, a horizontal ellipse. Now my hyperbola, this one opens in the y direction, so this is E. And that leaves this one to be F because it opens in the horizontal direction.